This video will demonstrate how to perform a pH titration and use the data from the titration curve to find the pKa of a weak acid. Take the pH sensor that you've already calibrated, rinse it off, and insert it through the hole in the drop counter. Attach the micro stir bar onto the tip of the pH sensor, making sure that the stir bar can spin freely. Position the pH sensor into the solution containing the analyte. The pH sensor must be positioned so that its tip is completely below the liquid level. Turn on the stir plate and adjust the speed so that the stir bar spins at a fast rate. Navigate to the graph in the SparkView software. You want to create a graph where the y-axis label is pH and the x-axis label is fluid volume. You can change the axes labels by clicking on either label. Choose the axis for which you want to change the label, click on the measurement you want to change, and select the new measurement from the list of options. Back on the graph, make sure that the sample rate is set to periodic, and press the play button to begin recording data. Open the bottom stopcock on the syringe to start titrant flow. Remember not to adjust the top stopcock. Adjusting the top stopcock on a calibrated drop counter will decrease the accuracy of the calibration. The graph shows how pH is responding to the addition of titrant. In this case, the pH is increasing as titrant is added. Feel free to use the auto scale button or to manually adjust the axes during the titration. This will not affect the data that's recorded. As the titration proceeds, the graph may take on some odd appearances at times. This is a side effect of the fact that the data is being recorded very frequently and the graphical display is having trouble keeping up. In the regions surrounding the equivalence point, the pH will change very rapidly. The goal of the titration is to capture the data in this region around the equivalence point and to keep recording data until the pH is no longer changing rapidly. Now we'll observe the data collection until the titration is complete. Now that the titration has reached the point where pH is only increasing very slowly, turn off the bottom stopcock on the syringe to stop titrant flow and press the stop button to stop recording data. Due to a software issue, the volume displayed on the x-axis may not represent the actual data that was recorded. To remedy this, advance the screen to the right and then come back to the graph. The graph will now display both the volume and pH correctly. Looking at the titration curve, you should notice that initially pH increases only very slowly, then pH changes very rapidly at the equivalence point, and after the equivalence point, the pH again changes only very slowly. To find the exact equivalence point, use the Select tool to highlight the data surrounding the equivalence point. Click Done, and then select the Slope tool. The exact equivalence point is the point in the graph where pH changes the fastest, or the slope is maximized. Slope is shown here as the value of m. Move the cursor to the left or to the right until you find the data point with the highest slope. For the data in this titration curve, the highest slope occurs at a value of 9.8082, and this happens at a fluid volume of 11.30 milliliters and a pH of 7.05. With the equivalence point identified, now deselect the Slope tool button and the Select button. The final step in the data analysis is to find the pKa of the acid. The pKa of the acid is just the pH at the half equivalence point. To find the half equivalence point, simply divide the volume of titrant at the equivalence point by 2 and use the Select button and Slope tool button to find the pH at this volume. While we don't have a data point at exactly 5.65 milliliters, the data point at a volume of 5.62 milliliters is close enough. Here, the pH at the half equivalence point is 4.17, and that pH is the pKa for this acid.